So we are going to talk about Veritas volume manager concepts. The concepts are very important for you to understand how volume management works in any operating system. So my objective is for you. I want to make you understand the volume management concepts so that you can apply this to any operating system, right? Linux uses volume management, you all done already, right? AX uses volume management, right? HP Unix uses volume management, right? Solaris also has its own volume management, but at the beginning Solaris didn't have a very popular volume management, so everybody started using Veritas, right? So that's why Veritas is still used on top of Solaris, right? Little by little they may change it to ZFS later, right? Yeah. So let me turn on the projector. So what you have heard about Veritas Volume Manager? What have you heard about Veritas Plus? Not heard? Veritas was owned by which company? Veritas was owned by Veritas, but now it's owned by? No. Symantec. They were making antivirus software those days, right? Yeah. Symantec owns Veritas. In the last class, you did like slices, right? In the class.
Yeah.
Yes, slices. Okay, good. So, what is the famous storage device you use? What is the most popular storage device you use at home and in the office? Hard disk, right? So, what is the advantage of hard disk? What is the disadvantage of hard disk?
This is portable.
Hard disk is portable. And what is the disadvantage? Limited in?
Storage capacities.
Storage capacity limited. Okay, then?
More chance of
Most chance for corruption. Every device has chances for corruption, right? We also get corrupted, right? Okay. What is the other disadvantage you would have seen? When you wanted to expand a file system, you have a problem, right? If you are using only physical hard drives, right? Right, physical hard drive. If you are using one physical hard drive, it is 1 terabyte. So maximum you can save is 1 terabyte, right? And if you have created a file system, right? And if the file system is already filled up, right, then you have problem, right? You can't expand your file system unless you back up, right, and then add another hard drive, bigger hard drive, and then restore onto that, right? So these were problems. So normally hard drive is accessed directly by the hardware or by the operating system. So users through the operating system, they access the hard drive. So hard drive is a physical component, okay? So that is why it has that limitation, right? What you see, you get, right? Nothing is virtual there, nothing is logical there, right? If the hard drive is 1 terabyte, that's the maximum you can get space, okay? Right? When I plan a business, I may think 1 terabyte hard drive may be enough for that file system, but when business grows, 1 terabyte may be nothing. So at that time I will have a problem, right? I can't waste 2-3 days or 1 hour, 2 hours to change a hard drive before that backup the file system and restore into a new hard drive, right? Because hard drive is something physical, right? So if it is 1 terabyte, it's 1 terabyte. I can't increase it, okay? Yeah. So you know a hard drive in Solaris Spark system is divided into different slices. It's divided into different slices. How many slices are there in Spark system in a hard drive? Yeah. 8 slices, right? So these are the 8 slices. the whole thing is Solaris partition. Solaris partition has 8 slices. So what is normally saved in the slice 0? What is normally saved in slice 0? What is normally saved in slice 0?
Operating system.
Yeah, root file system. Slice 0 is normally root file system. Then slice 1. Slice 1.
Swap.
Slice 1 is mostly swap we use for, right? This is if the hard drive is bootable. If the hard drive is not bootable, it doesn't mean 0 will be root. If the hard drive is not bootable, 0 need not be root, right? I can have 0 and I can install, I can copy data there, right? Right. So this is a structure, and then we have volume table of contents, right? And the first thing is you have 8 slices here, okay? So this is the regular physical hard drive, okay? Where is the information stored? All the information about the hard drive, partition table, partition tag, all those are saved in where? No, in VTalk. That is the place. That's called label. In that we have information about your slice. Okay. So in Solaris or in HP Unix, right? We have something like this logical naming conventions for hard drives, right? Based on the controller. If suppose this is a SCSI cable has different targets, okay? Say T0, T1. Okay, this is connected. Okay, we have 2 controllers in this motherboard. The first controller is C0, the second controller is C1, and if I have third one, C2, C3, like that, right? So with the C0, I have one hard drive connected here, right? What is the logical name of that hard drive? C0, T0, D0. That is the logical name of that hard drive. S2 means the entire Solaris partition. Okay. So what is the logical name of this hard drive? C0, T1, because it's connected to target 1 of the controller C0. Okay. And this one connected to C1. So it's going here. So this is called C1, T0, D0, right? And S2 is the entire Solaris partition. Okay.
It's not like we know, like this, the slice.
It's slice. That's what you.
Slices inside.
Yeah, these are slices. Okay. Yeah, these are the slices. Okay, this
Yeah.
is what you learned. This is what you learned so far.
Right. Yes. Slice 2, right? Yes.
Slice 2 is the entire Solaris partition.
Yeah.
Okay, so this is what you learned so far. Okay, and sometimes, most of the times, 1 or 2 hard drives in a server is not enough. Can you store all your data in 1 or 2 hard drives in the server? It's not enough, right? Right. So we may have to have multiple hard drives connected to a server. So we have multiple hard drives connected to a server. That is necessary. That becomes necessary, right? Because 1 terabyte hard drive, 10 terabyte hard drives are not enough for your data. It keeps on expanding, right? So we have a solution for that. We use disk array. So disk array is made up of multiple disks, okay? And all these things are connected to a Spark machine or a Solaris machine, Intel or Spark machine, right? So if I have about 10 hard drives here, each one is about 10 terabytes, 4 terabytes we say, I get 40 terabytes, right? So
each hard disk will have like a special connector, right? T1 like T2, right?
yeah, they'll have special connectors. Yeah. So these are small disk arrays for small data. If you want to increase the data a little, maybe few terabytes, you can use this. Okay. But the bigger solution in a company is something like this. So they have larger disk arrays. So each disk array can have hundreds of disks. Okay.
Is there a limit, like the size of it?
Depends on the manufacturer, right? The popular manufacturers are EMC, Hitachi, right? IBM, right? Hitachi is very popular. Hitachi EMC is very popular. So they have a lot of hard drives in the disk array. So these are large disk arrays. Okay, so this disk array can take a lot of data, right? So either they can have their data in a hard drive, single hard drive, or they can have the data in a disk array, or they can have the data in a large disk array as I showed you, right? Or another solution is NAS, network attached storage, right? So they can have their data, network attached storage is here, they have multiple hard drives here, right? It is connected to your own network. So it's part of your LAN, okay? Part of your LAN. So if you want to see a NAS, you can go to the server room. I will show you anytime when you are free, right? So it has multiple hard drives that can be stored, right? But it is part of the same network, right? That's why we call it network attached storage, right? So do some research on NAS, get some more knowledge in NAS also, right? Then we have something else called SAN. So this is a different network. Storage area network is completely different from the LAN. This is LAN. So all your Unix machines, NetWare machines, all these NT machines are here, or Windows machines are here. And we are using the regular switches there. But we have another network called SAN, where we are using different types of for fiber optic switches we use, right? And we have different network here. In that network, I have different types of storage devices. So the information from here comes to this network and it is stored. So if anybody want information, it comes from here and go to the user. So there's another administrator here called SAN administrator. And here we have network administrator. Okay. So do some research on SAN also, right? You should know a little about SAN, right? So what does SAN means? SAN means storage area network, right? So they use switches like brocade switches, right? So SAN is a completely entirely different course, different something. You have to learn like CCNP, like there are different modules in SAN, right? So you have to know how to configure those brocade switches, right? They are very expensive switches, several $1,000s each switch, right?
So, for example, if somebody is going for Unix for Solaris job, so do they demand a little bit about the SAN?
No, SAN is administered by a different person. If they already have SAN, that means they have a SAN administrator. But for you to talk to him, communicate with him, to work with him, you have to understand his language.
Oh.
For that reason, you have to know little SAN. Sometimes they ask for, right? But you don't have to be an expert in SAN. You can't be an expert in SAN. SAN is a different
Yeah,
something.
that's because there's totally storage.
Totally, yeah, different. So you have to know a lot of things,
Yeah.
right? Right. So one thing you should know is the worldwide name. So when you ask for, like in a large company, when you ask for storage, you're not going to take a hard drive for storage. You are going to get the worldwide name connection to a SAN network, and they will give you a slice of a something in the SAN storage. They give you a number. So you take that number as a slice. Okay. That is called worldwide name. Okay. So these are your servers, application servers. This is your storage area network. So you connect from here to here, get your WWN from the storage administrator, and then you include that in your storage medium, right? Whatever storage you are using. Okay.
Who was signed this is like
SAN administrator.
son of this?
Yeah, you have to request from him, then he will give it to you, or her, he will give it to you. Okay. So Solaris UFS file system, what do you think about that UFS file system? Are you happy about that completely or not very happy? Or you're very happy? Okay. Anybody who is not very happy about UFS?
Still it's okay, but gradually maybe.
Gradually? No, I'm talking about the weakness in UFS file system. UFS file system has some weakness. What are the weakness? Size. The file size is limited. Okay. Second problem.
Like ZFS have more like a particular.
No, don't compare this difference. UFS itself, what are the limitations?
Number one size, like maximum to 2 GB.
So size of the file is limited.
Yeah,
Okay. 2 terabyte. Okay. Then
Mounting and unmounting will be problem.
we have to always mount and unmount. Okay. Then how many slices per hard drive?
So maximum say
Maximum 8 slices. Out of the 8 slices, how many can you use it?
7.
6 only you can use. Even though you have 8, you can use only 6. Slice 0 you can't use. That is for root, right?
Yeah, and S.
Yeah. You can use it if you want, right? But even if, okay, consider that I can use it. Okay. But swap I can't use.
Yeah,
And slice 2 I can't use. Then 8 minus 2 is how much?
6.
6 only we can use, right? Even if I copy something in root, right? So even in i386 also, even though I have 10, I can still use only.
Swap.
Yeah?
Swap is a slice because
Swap is a slice.
we don't know exactly where swap is, right?
Pardon? Is connection something wrong? Pardon?
We
Swap?
don't know exactly where swap is, right?
Swap is in slice 1 normally if the partition, if the hard drive is bootable.
Slice 2, no? Slice 1.
Slice 1. Slice 0 is root if it is bootable, right? Slice 1 is this. Okay. It is also a slice. By default, when the system is installed, it creates a slice for swap. I can add files on top of swap if I want. So I can add more files as swap files. Okay. Yeah. So, and also mounted, then size of the file system. Size of the file system is fixed. So okay, I created a file system in a hard drive. It's about say 20 gigabyte, right? Then I started copying files. Now 19 gigabyte now. Now you know that anytime you are in trouble. Anytime it becomes 20 gig and people can't copy information. So what is the option? What can you do?
Extend.
What can you do?
Extend.
Extend. How you are going to extend?
You have to
Copy it, then you can extend other.
You have to back up the file system. Takes time. And then put another hard drive or find another hard drive or create another file system in the same slice. Then copy this back, restore back. So are you allowed, can you afford about 1 hour, 2 hour downtime? You have a problem, right? So you want to do this on the fly. On the fly, right? People like, on the go or whatever it is. People should not know. Your hard drive is full, next few seconds, you have solved the problem. People don't know that. So that type of situation only you want. Okay. So even though we can reduce the minimum free space, normally your minimum free is 3% or 4%. So it takes about say 500 meg, okay, or 5 gigabyte. You can reduce it, maybe you get 2 gigabyte. Small, temporary solution, right? Or you can back up and then do that, right? Or move to a larger hard drive or move to another server. These are the different options. But all these options will take time. Nowadays time is precious, right? So companies don't want to waste time, right? Right. We can also use hardware RAID, okay, rather than using software RAID. We have solution using RAID, right? Like hardware RAID we can use, software RAID we can use, right? But hardware RAID is expensive, and also hardware RAID is what? When there is a problem, difficult to find parts sometimes. Like when the RAID one part is missing, to get the same part, sometimes you may have a problem. When you're going to upgrade, when you're trying to upgrade current RAID systems, maybe the new RAID won't be compatible with the drivers in the operating system. So sometimes you will have issues like that, right? So hardware RAID is also not a very good solution for this. If I have RAID, okay, hardware RAID, I just buy hardware RAID and put it, the file system can expand. Okay, I can change the hard drive. Problem is always solved, but only thing that is not the right solution. Okay, so the right solution, recommended solution, cheaper solution, flexible solution is, okay, volume management. Okay, So when the slice keep on increasing, so your total data capacity is going, data is increasing, your file system space is reducing, volume management is a good solution. So you already know about some volume management software. Some of you have done Linux, right? Except for him, right? You don't know Linux, right? In Linux, they have built-in volume management. In AX, they have built-in volume management. That is related to Veritas. HP Unix, yes, but related to Veritas. Okay. So they all have volume management, but Solaris also had volume management software before. It did not have its own volume management software before. Okay. So everybody started using what? Veritas. Since Solaris didn't have its own volume management, people started using Veritas. So that's why Veritas is popular with Solaris.
SVM like Solaris volume manager.
That is in Solaris version 8.
Oh, in Solaris.
Yeah. Since before Solaris version 8, they didn't have any volume management software, which is their own.
Okay.
They were using something called Discrete. But Discrete also from another company called Solstice.
I heard this.
Yes, in Solaris 7 they had Solstice. Solaris 2.6 they had Solstice. But Solaris 8 they introduced Solaris Volume Manager. Solaris 9 Volume Manager. Solaris 10 ZFS is there. So Volume Manager is not necessary, right? But still a lot of companies started using Veritas and they have invested money. It's very expensive, Veritas, right? They have invested a lot of money. So still they are using. Maybe another 4 or 5 years time, maybe Veritas will go, volume management, and ZFS will come, right? ZFS will be the volume management for Solaris. But as at now, right, a lot of people are still using Solaris 9, Solaris 2.6, 2.5, a lot of people are using. So Veritas is a required, Veritas volume management is a required skill. And also, Veritas cluster is popular. Veritas cluster a lot of people use, right? So to understand Veritas cluster better, Veritas volume management will help you. Okay, if you understand volume management better, then you understand how cluster works. Okay, and also, you want to ask something?
Yeah, what is the difference between cluster and this volume manager?
Volume management,
Yeah,
I explained what is that. That means you have a problem with the file size.
Yeah.
You want to increase the file size, increase the file system size,
Yeah, we can
on the fly,
Yeah.
on the go, whatever it is, right?
Yeah.
Then volume management. That is one simple explanation, but it can do a lot.
Yeah.
Veritas volume manager can do a lot which other software won't do. That is why people like Veritas volume management. But simply I said that.
Yes. Okay.
Clustering is different, right? Say for example, a lot of users are connecting to one server to buy products. This server is connected to a disk array, and the disk array has the data. Disk array has the disk group, and the disk group has the data. Okay, so people are accessing this server, going to the disk array. Accessing the server, going to the disk array. Everything is smooth. Okay, this server crashed. What will happen? Everything goes. The company will lose maybe millions, or maybe thousands, or maybe 10,000s, depending on what business they are doing. Even a few minutes, they may make big loss. So if this server die, another server should take ownership of this disk group. Another server should take the ownership of this disk group. So that is done in Veritas cluster. So we will have cluster of servers which can share the same database. Disk group has the database.
Similar to mirror.
No, not mirror. Mirror is computer. That is one computer. One computer, 2 hard drives. That is mirror, right? This is 2 different computers. Okay. So in Linux and all, we are using something like this. So users are logging through volume manager, okay, and then they go and access their real data here. But really, the data is coming from the hard drive. But people don't know that they have hard drive. When you learn Linux, you don't know that they're using hard drive. Did you know? You are losing volumes. So that really they are actually mapped to hard drives. Volumes are logical. But operating system will access the hard drive through the logical volume manager, logical volume. So users also will access the logical volume. But when you say a volume, you're talking about hard drives, maybe multiple hard drives, or maybe part of a hard drive. Okay. So that is in Linux environment. Then when you look at Solaris 7, actually in 8 they said it's going to be obsolete, right? That's why I put /8. After Solaris 7, you had something called Discrete. So in Discrete, I can take chunk of data, a slice, and then I can create some meta devices out of that. And this is the logical one. Meta device is logical. So I'll take slice from here, a slice from here, a slice from here, give it to Discrete, and I make a meta device. So meta devices are named like D0, D1, D2, D3, like that. Same like volume manager. Solaris volume manager uses D0, D1, D2. It follows the same thing, right? But this is this 127.
Like from which, like the physical A is, how many slices can we take?
Yeah, something like that. Yeah, what is that?
Say, physical disk A.
Yeah.
How many slices we can take?
Oh, in disk we can take, yeah, or we are talking about sub disks. Sub disks we can create any amount.
No, like
These are like sub disks. These are not real slices.
No,
Yeah, don't worry much about solstice.
no, you said we take, let's say, from physical A, B, C.
Okay, this is a physical hard drive. In the hard drive, I can create small sub disks. We'll talk about that in Veritas. Right? We can create a lot of sub disks anyway, right? When we are using this suite, right? So in Solaris 8, they introduced what? Solaris Volume Manager. They introduced something called Solaris Volume Manager to manage the volumes. Okay. So that means I can take different slices and join them together and create one logical volume. So when users are here, users are accessing the hard drive directly. Are they accessing the hard drive directly, or are they accessing this?
they are accessing this one.
This,
volume.
yeah. You answer, I watch you. Huh? So they access this. They don't access this. If they access and play with this, then you are damaging the data. Okay. So they access this, and from here it goes there. Okay.
No, I have one question. Like D21 is that the four hard drive is there. It's 4 terabyte.
Need not be hard drive. Can be slice, can be sub disk, can be anything.
Okay, there is a space like a 4 terabyte or something.
We assume 4 hard drives. Okay.
Yeah. Then how much we can get in logical volume?
Depending on the size of this hard drive.
Yeah, does the hard drive size is like 4 terabyte?
Yeah, then we can get 4 into 4.
4
4 into 4 is 16.
16, and what will be the logical volume?
If I take only this 4, I will have 16 terabytes here.
Okay.
Yeah, that is available. But we can control. We can take only 5 terabytes. From this, we use only 5 terabytes for this volume. Another 5 terabytes for another volume. Like that we can create. Don't worry about that. We will talk about that. Okay. So if this is 16 terabytes, I can go up to 16 terabytes. But I don't have to go up to 16 terabytes. It can be less. Okay. I can have multiple volumes. So Veritas Volume Manager can be used in any operating system. So all what I said is for different operating systems. That is another beauty of Veritas Volume Manager. I can use it for Windows, Linux, HP, Linux, AX, anything. If they are using, it has derived from Veritas, right? But the main partner is Solaris, right?
So you mean in the volume, in that volume, right?
Yeah.
But before that we have to create like file system, right? File system we have to create.
Yeah, we'll come.
Yeah.
Yeah, we don't worry. We just go by this. Yeah. So what we do is, so I have a lot of physical disks here. I will use these physical disks to create what? Volumes. Volumes are logical or physical? Logical. So now if I have 4 hard drives, each one is 1 terabyte. What is the maximum size I can create?
Yeah, 4.
I can have maximum 4 terabyte, right? One question. Where is the question? Must be installed on server, can be installed on Windows servers and manage Solaris Linux servers. Must be installed on server or can be installed on Windows servers and manage Solaris Linux server. Yeah, of course. Yeah, we'll be learning that. Yeah, just like virtual hard disk instead of us. Yeah, like that. And 6. What is 6?
Before we asked for slices, how many slices?
Oh, how many slices? Okay, good evening. So, multiple physical disks are used to form volumes, and volumes are accessed by operating system, and users are accessing from the operating system the data, through the operating system the data. Is the operating system directly talking to the hard drive? No, operating system is not directly talking to the hard drive.
Veritas volume manager is talking to hard drive, and we operating system talking to Veritas volume manager.
Yeah, Veritas volume manager talking to hard drive, and operating system talking to volume, and we are talking through operating system to the volume, and our data is saved where?
Like for us, like in the volume manager, but physically it stores on that.
Physically stored here. Our data is stored here. Our data is stored here. Okay? Understand what I mean now?
Yeah.
You understand that concept very well, right? What about you? Yeah. So you have $100, you have $100, you have $100, you have $100. So you are putting $400 in one table. So we have $400, right? But each one have only $100. So together we have $400, something like that, right? So $400, you have $400 now, but it's virtual. You also have $400, it's virtual, right? But you can go up to $400, buy things up to $400, right? Yeah. Know what I mean? So in Veritas, yeah, it can't be larger than total disk amount. It has to be total disk amount. Total disk amount is the maximum, right? So we have in the Veritas, normally Veritas can use UFS, right? Veritas can use UFS, and also Veritas can use Veritas file system. So the traditional file system for Veritas is Veritas file system, right? But it can use UFS, no problem, right? Okay, so we have the physical hard drives or disk drives or whatever it is. We are creating volumes based using this. The volumes are created. From the volumes, users are accessing the data. Okay. It can be data, it can be application, it can be anything, right? Okay. Okay. So if you take the VXVM architecture, it has some daemons. Everything should have daemons, right? Right? Daemons are there. Some drivers are there. And configuration database. What I'm doing a lot of configurations. My information has to be saved somewhere, right? I'm creating some volumes. The information about volumes has to be saved somewhere, right? So that is saved in VXVM configuration database. Then I should have device drivers so that volume management can talk to the hard drive. How can volume management talk to the hard drive if there are no drivers, right? So that is component also that most probably from operating system it can use most probably. Then I have block device, character based device, then daemons. These are the different daemons are there, right? And then we have how to configure a volume manager. You use command line or you use graphics? to configure the volume management. Huh?
Command line.
Command line you can.
Command.
Command line. Graphics you don't use? We can use graphics also. We can use command line. We can use graphics. We can use menu driven utilities also. Menu driven utilities also we can use. So I can use three things to configure and manage Veritas. Okay. Which one is the best?
I prefer
Depends on the company requirement.
You prefer what?
CLI.
You prefer what?
command line.
See, when he came first time, he said, I like graphics. Now he said, command line. What do you prefer?
Command line, like
Command
in the
line.
job.
Yeah, I can't go to different servers and run the graphics and it will be very slow, right? So command line, I can log into any server in any part of the world, right? And quickly type the commands, right? Okay. So these are the daemons. vxconfig d. If these daemons are not running, as that refers menu. Okay. If this menu problem is you can make mistake. Graphics also you can make mistake. Command you can't make mistake. If you make mistake, it will complain. Your command syntax is wrong. At least you get a warning, right? In graphics, everything is there, so you click, it will work, right? Yeah. Okay. So there are daemons: vxconfig d, vxio d, vxrelock d, right? vxconfig backup d, right? All these daemons are important, right? We'll talk about these daemons little by little. But vxconfig d as at now is very important. If your Veritas is not working, you have to check whether this daemon is running. Configuration daemon. IOD daemon, if it is not running, then your devices cannot be accessed. Input-output daemon. Yeah, so it cannot be accessed. This is for backup. I can back up my VX configuration. Whatever configuration I have in the Veritas, right? I can back up also if I want, right? For that you use this. Okay. Anyway, we'll talk, but this is just a basic introduction, right? But we'll talk about these things later. Any problems so far? Everything okay? Santosh, fine? Huh? What about you, Headshot? Fine? What about you, James? Quiet, James? Fine? Yeah, pretty good. Is Veritas backup included in volume? No, backup is different product. Backup is to backup. And Veritas backup is not that popular now like those days. They use Tivoli now. IBM Tivoli is good for backup. So they use IBM Tivoli for backup, right? Yeah. So this is just for your knowledge now. If you want to know, you don't have to know that. Okay. When there's a problem, you make sure vxconfig d is running, vxiod is running, right? Right. No, they are backup products also. Tivoli backup is very popular, right? Okay, so what are the steps to bring a regular disk or a disk array or a disk in a disk array under VM control and create file systems in that? What is the basic step? Tell me. First I have to.
There's partition.
No, look at the screen. You have the answer on the screen.
Yeah, I have one question.
You are looking at Solaris. No, forget about Solaris. We are in volume management now.
We'll get this.
I'll get some notes for you.
Okay. Yeah. That's it.
Okay, so
Great one.
tell me what I should do when I want to. You want to form a group. 4 people want to form a group. First, you have to. Okay, you are selected. You are selected. You are selected. There are about 15 people, so you have to select people, right? So likewise, you have to initialize the disk and tell you are part of Veritas now. You are part of. That is called initialize. So first thing is initialize the disk and make it a VM disk. What do you mean by VM disk?
Can you do part of this?
No, full. How can
Full
you?
disk.
No, full disk. So what is VM disk? Volume manager disk, right? So you initialize a disk and make it a VM disk. Okay. Will it take a long time to do that? How much time you think? 1 command or 5 commands?
One command.
Just 1 command. Okay. I can do it in many ways, through a menu, or through a command. Which is better?
Command.
Command is better, right? That's why command is used. And command is accurate. So if I make a mistake, I will know. But don't initialize the operating system disk accidentally. Okay, I will give you a precaution for that, right? Don't initialize the operating system disk in this server, right? Yeah. Then after I initialize, then what do? Okay, I have selected, okay, out of these 13 people, I have selected about 10 people first. So that means 10 people are initialized. But now you are forming a group. You are forming a group. What is the name of the group? You want to share the money? Money group. So you are forming a money group. Then you are selecting one guy, another guy, another guy. So that is create a disk group. So out of the initialized disks, you are selecting a few and making a disk group. Okay, disk group. So this disk group will have data which is what?
Which is not
Similar.
yes, similar.
All same type of data only we put in this. Okay.
Explain it again.
Pardon?
So explain it again because you have just selected the disk, right?
So I initialized many disks. So after initializing many disks,
And let it know that it's going to be a VM disk.
yeah, then I tell that this is going to be the VM disk. These are going to be the VM disk. Okay. Then what I did after that?
Okay.
Then I selected few of them, and then formed a group, disk group.
Not all.
Yeah, not necessary. If you want, you can all. That's not. Yeah.
Should those disks be
Yeah.
similar in size, in brand, or
No, it doesn't matter.
doesn't
Can
matter?
be anything. Yeah,
Like you can have 1 terabyte and 2 terabytes
yeah, no
together?
problem. No problem. Yeah.
Actually,
It doesn't
how
have to
you
be
can-
same size.
how
Doesn't
you
have to
can
be
create
same
the
brand.
RAID then?
Pardon?
How you will create the RAID?
No, because we forgot physical disks. Forget about physical disks. We are talking about logical disks. So it doesn't matter. If you are talking about physical disks, if you are making two physical disks, if I am joining two physical disks to make a mirror, then I have to worry about same size. But now I'm putting everything in a disk group, right? And then making two out of the disk group. So this size doesn't matter. The thing I am taking from the disk group and making the mirror, that those things are important. Okay. How are you, Pradeep? After a long time.
Traffic was exhausted.
Oh yeah, I know. Okay. Then, okay. After I create a disk group, so four people joined together and made a disk group. Okay, you made a group, money group. Okay. Can I add another person later? Can I?
No.
Yeah. That's why you had to use add additional disk.
Yeah, we can add.
You can add additional disk to the disk group, right? Any number? A lot of disk you can add, right? Don't worry about the limitations. What is subdisk? What is subdisk? Subdisk is a portion of a disk which is continuous. I can't take this piece here and make a subdisk. A portion of the disk which is continuous or whatever it is. So that is a subdisk.
Subdisk is like portion
Portion of a disk
group,
which is continuous.
of disk group you mean. So.
No, portion of a disk.
Oh, of a disk.
Portion of a disk. So in a disk group, in one disk, I can take one piece. Is it equal to a slice?
Like we can say like this.
Yeah, it's like
We can say like
slice.
for some.
It's one slice.
What is the relationship of that with the slice? Subdisk and slice. What is the relationship?
That's under the operating system. And this
Fine.
is the-
What is?
The slice is under the operating system, and this
Yeah.
is like the subdisk is under the volume manager.
Yeah.
Yeah,
Subdisk
so-
has nothing to do with slice.
Yeah.
What is subdisk? What is slice? Subdisk, we forgot about slice now because we have made everything under volume manager control. So we have no physical, we don't have access to physical devices, right? Yeah. What is?
If we put the physical disk together now instead of a logical disk,
Mhm.
and then we are going to create a sub disk out of that logical disk.
Yeah, correct.
So we are not actually taking it from the physical disk. We're taking
But we
it
are
from the
using,
logical
we are taking that subdisk from one physical disk.
Well, how
Okay.
you could know that physical disk if everything is in one?
Okay, so these are two disks which are part of our disk group. So when I am creating subdisk, I told you the condition for subdisk is it should be a continuous portion of the disk. So I can't take one piece from one disk and another piece from one disk. No, it has to be continuously in one disk.
So do you take it before you create the logical volume or after?
Before creating logical volume, because we can use those subdisks to create volume.
Okay.
Yeah. So, for example, all of you put $100 and made $400 in your disk group, in your money group, right?
Yeah.
If I want, I can I can take that $100. I can divide into two. I can take $50. That is a subdisk. But the condition is you are always take from one person. I can't take 25 from him and 25 from you. No, right? I take 50 from him, 20 from you, like that.
This stays 400 or should it be 350?
To tell me again?
The volume, if you take 4, right?
Yeah.
100, 100, 400, the volume, right?
Yeah, yeah.
If you're doing subdisks, the volume is going to be 350 or 400?
400, 400.
400.
No, the volume, we didn't come to volume yet. We are talking about the money group or disk group. So we are taking 100, 100, 100, 100. So altogether how much we have? 400.
So my volume is 400.
No, we didn't talk about volume yet, disk group. We won't go to volume today. So we are talking about disk group only. We are joining five disks or 4 disks together and forming a group of disks. That group of disks is called disk group. Later in the next class, we will make volume out of that. Okay. So if I have 4 disks, each one is 1 terabyte, my disk group total capacity will be 4 terabyte. In that 4 terabyte, later I will create any number of volumes. But the total volume size should be how much?
4 terabytes.
4
It
terabytes.
will not exceed the 4 terabytes.
It can't exceed 4 terabytes.
Okay.
Yeah.
So we have a disk group of 4 terabytes.
Yeah.
But you're saying also out of that 4 terabyte, from one of these we can make a sub-disk.
Yeah. I will explain the why subdisk. Okay. So how many disks I have? 4 disks. Each disk is how much? 1 terabyte. Oh, I want to create so disk group is 4 terabyte, but I want to create a volume which is about half terabyte. How will I create a volume which is half terabyte? I can create. If I want to create like that, it's good for me to break the disk into sub disks. So if I break 1 terabyte disk into 4 sub disks, 250 gigabyte each, I will take 2 sub disks, 1 sub disk from this, 1 sub disk from this hard drive, and make a volume. That is why I create sub disk. Right? You have a big cake. Rather than serving the whole cake, you cut the cake into pieces, sub disks, and save and serve. Something like that. Huh?
Windows partition or something? Like a Windows partition?
You can't compare with that.
Almost.
No, that is physical. That's why. Because this is logical. Yeah, you can't compare with that. So you have something logical, but only condition for subdisk is it should be continuous. So I can't have subdisk, portion of the subdisk in one hard drive, another portion of the subdisk in another hard drive. How can I have? It's not continuous. And also in a hard drive, I can't take a piece from top and take a piece from bottom and join and take one subdisk. No, that doesn't work. It has to be continuous portion of a hard
You can
drive.
put more than one sub-disk together to make a volume.
No problem. No problem. So you understood now what is physical disk.
Yeah.
You understood clearly. What is logical disk? You understood clearly. Okay, you didn't understand clearly? Okay.
I have a question.
Yeah.
Can we do sub-disk after sub-disk?
Yeah.
Oh, yeah. Sorry.
Yeah, but we don't do that. No, I have never done that. I think it should be, I cannot say yes for that also because I have not done that, right? Yeah, there was no need. So if suppose I want to make a very small subdisk, I'll make initially small subdisk. Okay, right? So physical disk, then logical disk, and subdisk, disk group. What is disk group? What is disk group? No, I have to ask him. He's for only part 1, only 2 lessons he has done. Okay, 1 lesson he has done. Okay.
This group is nothing but putting all the disk in one group is called a disk group.
Yeah, also disk which is going to do a similar function,
That's it.
which is going to do a similar function in one group, and we make it a disk group. Okay, then what is the other one?
Subdisk?
Subdisk. Yeah.
Subdisk is nothing but taking the partitions from the disk group and creating other.
No, don't say partitions.
Taking from like one part from the disk group.
One continuous part
Yeah,
from
one
a disk.
continuous part from the disk group.
The disk from a disk in a disk group.
In a disk group. Okay.
Yeah, from one disk in a disk group and using it
Using it in other.
maybe in the volume later. Okay,
So that's called a subdisk.
that is subdisk. Okay, clear? Can I make one subdisk with 2 hard drives in a disk group?
No, continue.
So that's why I told you should be confused. Okay, so initialize a disk first and then create a disk group and attach this disk. Can you create a disk group without attaching a disk?
Attaching a
Disk. Can you create a disk group without attaching a disk? Can you have a wedding without the bride?
It's not physically not possible.
Possible?
You need the physical, then you can.
So likewise, we can't have a disk group without a disk. So we have to have minimum how many disks? Why two? One? No, he's thinking about wedding. His mind went there.
We can create from one group. We can create a volume from one disk group.
Yes. Yeah. Can you add additional disk to a disk group?
Yeah.
Can you remove the disk again back if you don't want?
Yeah, yeah, we can.
Can we?
Yes.
Yeah. Can you create subdisk? Yes. What is Plex then? Plex.
Collection of subdisks.
Collection of subdisks or collection of disks.
Also,
Collection of subdisks or collection of disks is called Plex.
next.
Plex.
A little bit further, if we already start using those disks, say suppose it's in a volume and we are using it, can you still remove a disk out of the disk group?
Yeah.
Without losing any.
No. We have to remove something which is not used. Yeah. It doesn't mean when you say remove, you can remove just the one where data is copied. No. Then in that case, you have to evacuate the data from there to another hard drive and then remove this hard drive after removing from the disk group.
Yeah. Now.
Yeah.
How do we know which hard drive is stored data, which hard drive is?
We'll come to know.
Oh.
Yeah. What is that?
Okay, if the disk fails.
If the disk fail, we normally have a spare disk, so automatically that spare disk will take over.
And the data is going to be copied automatically from the hard drive?
Yeah, if it is mirror, it will
If
synchronize.
it's not mirror, I have to.
You want to do
Now, depending on what RAID you have.
Okay.
If you are having RAID 1, it is mirror, so it will copy the data there. If it is RAID 5, yes, it will do that automatically. But if 2 hard drives fail, only problem. In RAID 5, if 2 hard drives fail, then you have problem. Yeah. You know RAID, right? You know RAID. You would have learned RAID in your course. Okay. So plexes, what is plexes? Plexes are made up of subdisk or disks and used to make
Disk group.
why disk group we have finished. We used to make volumes. Plexes are used to make volumes.
What's the difference between plexes
Yeah.
and disk group?
Under the disk group we have VM disks. Okay. Within the VM disks I can have subdisks. I can use subdisk to create plexes.
Also, you're not using all the disk group, you're just using just.
Yeah, a portion of it. Okay. Under the disk group, we have VM disks. Under the
We have some disks.
under the VM disk we have
This group we have this.
sorry. Under the disk group we have VM disks.
VM disk we have
In VM disks we have subdisks,
subgroups.
and those subdisks can be used to build plexes. Plex. Don't worry about other things. Plex is used to build volumes. Don't worry about that. We didn't come to volume yet. Yeah.
They say you have the disk group before you have the VM disk.
Pardon?
You have disk group before you have VM disk.
No, no. VM disk first and then disk group only.
Then this.
Yeah, yeah, yeah.
Out of this group, you can, if you want, you can make sub-disk.
Yeah, yeah.
And then more than one sub-disk together will make a plex.
Plex, yeah. And we can make, one plex can be a mirror. So we can have two plexes to make a two-way mirror. Like mirror means the data is copied in two hard drives or two plexes at the same time. So if this plex dies, then we have another plex.
Why we would create this group and then take out sub-disk and make plexes? No, you said to make mirrors within this group.
Yeah, yeah. We'll come to that. Yeah. So create volume in a disk group and assign disk space from subdisk to volume, right? From subdisk to volume we give, right? These steps you should understand, Amina. I mean, Faisal, you also understand. But even if you don't understand, you will understand later, right? If you understand now, it's easier, right? Right? That's why try to understand. This is not much, right? Like you are learning something, maths or something at home, something like that. It's not really IT, right? Like this order you have to remember, right? Yeah. Then create a file system in the newly created volume. I created a volume. I want people to use it. So I have to create what? File system. File system I am creating on a physical device or a logical device? Logical device. Earlier you were creating in Solaris physical device. But now we are creating a volume. We are formatting the volume. Formatting a logical device. So actually that is formatting the subdisks. Subdisks. Oh, sorry, not subdisks. Real disks. Real physical disks. Right?
I have a question. Before we create this group or make this group, those disks has to be like formatted or not?
You don't have to format.
Just choose like as it is new.
Just any disk. Any disk. Don't worry about that now. We will come to that. Yeah. Then I have to make a mount point, and then I have to mount. After mounting, use and enjoy. Okay. So these are the steps for one of our lab. Okay. But this is not one lab. There will be a lot of things you can do in Veritas Volume Manager. We are not using Veritas Manager only to do this. Okay. We can have very complicated, rates, right? Right. So all those things we'll talk later. So what is the first step when you buy a brand new system? What is the first step? You have to first install the operating system, then install what? Veritas Volume Manager. Then after that what? So put some disk accessible to the operating system. It should be first accessible to the operating system, right? Then after that you make the disk VM disk, right? Yeah. VM disk. What we should do to make it VM disk? Initialize. So it's there on the screen. Initialize the disk to make VM disk, right? Yeah. Then after we become VM disk, what do? We create a disk group with them. Then after that in the disk group we create volumes. We create volumes. We don't have to create subdisk. We don't have to. We can create volumes directly, right?
So what's the benefit of these subdisks?
Subdisk is like find small sizes I can use in different places rather than using the entire 10 terabyte or 5 terabyte hard drive, right?
Just for splitting them up.
Yeah, splitting them up. Yeah. You don't want to use the whole hard drive, right? Yeah. Another reason is I want to create a volume. But for that, I want to use a small piece from this hard drive, small piece from this hard drive, small subdisk from this hard drive, subdisk from this hard drive, and I want to make a flex. Why is that? Why can't I make from one hard drive flex? Why can't I? Why I want pieces from?
Security, protection.
Security or what?
You want to save space on those other disks.
Redundancy. For redundancy. And for redundancy may or may not help based on my RAID, right? That redundancy depends on my RAID. Okay. Another advantage is faster reading and writing, because I'm using different controllers from different hard drives. Okay. You know what I mean? No? It's clear? Clear, right? If you are clear, put up your hand. Put up your hand in front of me. Okay. What is that? Not clear? Okay. What is not clear? Don't worry about subdisk now. But what about, okay, can you understand this? We take the physical disk, we initialize them and make them what? VM disk. Then after making VM disk, we'll put the VM disk in a disk group. And after putting the VM disk in the disk group, we create volumes. Don't worry about subdisk. We create volumes. Okay. So volumes are within where? Volumes are within the disk group. Within the disk group. Disk group is made up of VM disks. VM disks are made from physical disks. Okay, you understand? Why? Only 4 things. Why?
I'm looking at this diagram that you did.
Yeah. What diagram? Okay, another nice diagram will come. Don't worry. Okay. So we look at this diagram. Okay. So now this is my physical disk. This is my physical disk. I did something and then this became VM disk. What did I do? I did initialization, right? So I initialized this and this became VM disk. Okay? Okay. Let me do that.